So in 3.5, we're going to talk about rational functions, and in this video, we're also going to talk about their domains. Now, we've looked at rational expressions before and rational equations, so it might not be too shocking to you. Here's an example of a rational function right there. Okay, so a rational function is some function, say f of x, where the numerator is a polynomial and the denominator is a polynomial. And that's all it means. Just you have one polynomial divided by another polynomial. Okay, so in this example we have the numerator, as a quadratic, fine. The denominator is actually factored for us, which is going to help us. When we talk about the domain, we have to say that q of x cannot equal 0. Remember, we're not going to divide by 0. So when we're trying to find the domain, we're looking at when does that denominator equal 0? When does x times x minus 2 times x plus 5, when does that equal 0? Because we can't have that. Now, I don't know if you want to use the equal sign or the does not equal sign. It doesn't really matter to me. I think in some ways it makes more sense to use the does not equal sign, but a lot of times they'll just put equals because we're trying to find when does the denominator equal 0, and then we're going to say that's what we can't have in the domain. Okay, so hopefully that makes sense. We use the zero product principle. It says x can't be 0. X minus 2, whoops, x cannot be 0. X minus 2 cannot be 0. And x plus 5 cannot be 0. Okay, so the values we cannot have in our domain are 0, 2, and negative 5. Now, you want to think about this on a number line. You don't have to draw the number line, but it might be helpful, especially for like the first one or something. So we cannot have negative 5, we cannot have 0, and we cannot have 2. But everything else we can have, like all the other real numbers are great. We just can't have negative 5, 0, and 2 in our domain. And I say to make the number line so that you can read it from left to right. So we're going to use interval notation now. The domain is going to be from all these numbers, negative infinity to negative 5, don't include the negative 5, union all these numbers, the ones in between negative 5 and 0. Okay, great, but not 0. And then all these numbers, the numbers between 0 and 2, those are all good. And I'm going to run out of room. And then we're going to union that finally with all these numbers, which is going to be 2 comma infinity. It didn't quite fit, but that would be the domain. That's a long domain. Okay. So basically there were 3 values that we can't use. We can't evaluate the function at those 3 numbers, and so we have to take them out of the domain. Okay, so here's an example. Well, 3 examples, I guess. So we look at the, sorry about that. We look at the first one here. We have x squared minus 9 over x minus 3, and it asks us to find the domain, so we're just looking at the denominator. So what can't we have? Well, x can be 3, because that would make the denominator 0. So we are going to say everything from negative infinity to 3 is good. And we're going to union that with 3 to infinity. That would be all real numbers except 3. This is called the interval notation that we're using. So, ta-da. Now, if you're really thinking about this one, you might think about, well, couldn't I factor the numerator and cancel a factor and blah, blah, blah. You could, and we're going to talk about that later in this section and what that means. But when you're doing the domain, it's before you do any type of simplifying. Okay? All right. Hopefully that helps. All right. So the next one we're saying, when does x squared minus 9 equal 0? Well, you could say, when does x squared equal 9? And square root of 9 plus or minus. So I can't have it be 3 or negative 3. Or you could have factored it. I was going to factor it, and then I thought I'd do this. Okay, so I can't have, this is what x can't be. It can't be negative 3, and it can't be 3. So my domain, negative infinity to negative 3, union, negative 3 to 3. Those numbers work. Union, 3 to infinity. And again, you could make a number line to show that. That might be easier for you. But you want all the real numbers except 3 and negative 3. See, those won't work. If you plug either one of those in, it's going to make the denominator 0, and that's a problem. Okay. When will x squared plus 9 equal 0? Well, you could do the same type of thing. You could say, when does that equal 0? And you could subtract the 9. You have the abilities. You could take the square root of both sides. But see, it's negative 9 this time, and so that means you're getting plus or minus 3i. That is not real, okay? Because we have a function, and we're going to eventually graph these in the real number system, they're not real numbers. So our domain is only over the set of real numbers for our functions, and so those don't, they're part of it. So all real numbers will work. The domain is going to be all real numbers. Okay, and there we go. If you want to think about it a little bit more, there's no number, no real number that's going to make the denominator 0. So you're going to square something and get it positive, no matter what it is, and then you're going to add more positive. So it's just going to be a positive number. There's no chance that it's going to be 0. Okay.